Hi everyone, welcome to our online video lesson series. Today we'll be going through an organic chem prelim question from 2019 paper. So this is on electrophilic substitution of amines. Okay, so benzene is nitrated by concentrated nitric acid dissolved in concentrated sulfuric acid as follows. So you can see that the benzene is reacted with an electrophile, which is namely a nitrate, and then you have an intermediate given, and finally the final product. So the question is asking which of the following correctly represents the reaction profile for this mechanism. Okay, so this nitration of benzene is basically a two-step process. So what happens in the first step is that the benzene, which is highly rich in electron, will be attacking the nitrate, which is deficient in electrons. All right, so this actually causes the production of a carbocation, which is actually sp for orientation. Okay, so you have this carbocation, and we call this a slow step. All right, so the second step is basically the reaction of the carbocation with a negatively charged ion, which is produced from the sulfate. Okay, so this is a carbocation here. So we have NO2 and H. Okay, so this is going to basically react with the HSO4 minus in order to actually get back your complete aromatic ring structure. Okay, so this you will get your nitrobenzene out as a product as shown in your overall equation. So what happens here is that this is actually a fast step. So the reason why this is a slow step and a fast step is because a slow step has a very high EA, which is activation energy. So if you're going to draw the EA for the first step, it is basically going to have an energy pathway that will be endothermic. So you will have a high EA that is endothermic. So this is the energy and this is the reaction pathway. Okay, so as for the second step, if you are going to draw out the reaction for the fast step, it is going to be an exothermic reaction whereby you will start off with somewhere where you left off the first step, and then you have a very short EA followed by an endothermic reaction that leaves your products here. So this is your final product, nitrated benzene. Okay, so this is your EA for the first reaction, EA1, and this is your EA for the second reaction. So you can clearly see that EA2 is much lesser than the EA1, which makes it a faster step, and the first reaction is a slow step. So right now, in order to obtain our answer, we have got to combine both the energy cycles, energy reaction pathways for both these steps in order to get the reaction profile for the overall mechanism. So what happens is you will have this overall axis, and nitration of a benzene, just to let you know, it is an exothermic process. Okay, so this is an exothermic process with two steps inside. So the first one is going to be like this, then it will take another turn because of the second reaction, then it will end off here. So this EA is basically attributed to your first reaction, so you can call it a EA1, and this is EA2. Okay, EA2. Therefore, the answer here is basically option D. Okay, so the reason why option C is out is because C clearly shows that there's only one step to this mechanism. However, this mechanism, as you can see, it has two steps to it. Hence, the options A, B, and D have clearly shown that there's two steps to it. And looking at options A and B, option A shows that your product is neither endothermic nor exothermic. So therefore, this is wrong. And option B shows that the production of the product is endothermic. However, the nitration of benzene is an exothermic process. Hence, the answer is going to be D. All right. Thank you so much for watching our online video series. Do follow us on our Instagram account and like our Facebook page to view more of such videos. Also, refer your friend to obtain special rebates. Thank you and see you again soon.